All right, so today we're going to sketch and label the vertex, the max min, the axis of symmetry, the x-intercept, and y-intercepts of f of x, g of x, h of x. And again, very quickly, you should identify all three of these as quadratics, which are parabolas. All right, and I'll just go through them one at a time if you want to practice them ahead of me. All right, we'll make sketches and graphs. We'll do it by shifting the parent function or the mother function y equals x squared. All right. So we know we want to make it kind of look like our parent function, f of x equals x squared. Well, right now the big problem is we got to get that negative out, which makes it open downward. All right, I don't disagree with that. So it is going to have a max. We know that just from the negative group. It opens downward. But we pull this out, and again, at this point, we've changed nothing. Now, I know I want to get this into a format like this. I want it to be something squared and plus some number. I got to fill some blanks in here and here. But right now, to do that, I'm going to need a trinomial here. Well, again, we are getting good at our perfect square trinomials. We look at 4, half of 4 is 2, 2 times 2 is also 4. I put that in here. I'm just not allowed to drop a 4 out of the sky. I got some rules. If I do it on one side, I got to do it on the other. Or if I add 2 to a problem, I got to subtract 2. If I add 12, I got to subtract 12. If I add negative 9, I got to add 9. In this case, I have subtracted 12 on the right side. Because negative 3 times 4 is negative 12. So I'm going to have to balance that with plus 12. Now, I'm not going to do it, but everybody, we should realize at this point, if I square out, if I multiply this out, it had better be exactly the same as this. We are not allowed to change the expression on the right side. But we are allowed to reorder it, and that gives us amazing power because we get to this. And all of a sudden, this looks like our mother function. All right? So I'm going to move down the page. We know that a parabola, y equals x squared, looks like this through the origin, opening up. So we start inside. What makes that 0? Negative 2. So this is 2 to the left. Boom, boom. What's the negative 3 do? It flips it upside down, and negative 3 makes it happen more quickly. So if this was negative, just a negative 1, negative 3 is going to make it go much quicker. I'm just sketching it. And then I'm moving it up 5 for the last number. All right, so I'm going to get rid of all those black curves. I'm 2 to the left, 5 up, down, and fast. So I get those curves out. 5 up. Now, before I draw it, sometimes it is easier for me to put the y-intercept in on the y-axis here. And I can do that very quickly by going to the original problem. If I plug 0 in for x, you guys agree f of 0 this time is negative 3 times 0 minus 12 times 0 minus 7 is negative 7. And you're going to say, Mr. Anderson, why bother? Well, the only reason why bother is if I want to sketch it now, at least I know negative 7 is somewhere down here. And look at that. Now, it's not a great sketch. It's actually kind of crappy. But it's there. I just sketched it. And I have found the y-intercept at the same time. The y-intercept is negative 7. Is it a max or min? It is a max. And it's a max of 5. The vertex we know is negative 2, 5. We located that. Again, that is point D here. That's the T. The axis of symmetry comes from the vertex, where the max is 5. The axis of symmetry this time is the vertical line, x equals negative 2. And that leaves one very ugly calculation for us to complete. I have to find the x-intercepts, which are located here and here, right? Well, the one thing I know about the x-intercept, when you have an x-intercept, the y value is 0. So I'll do it in red here, and I will set my not my original equation, but the equation I created of the mother function, because it's more or less completing the square. All right, we're there. I'm going to set this equation right here equal to 0. This one's going to be 0 on this side. So I'll write that. 0 equals negative 3 x plus 2 squared plus 5. Now, I will move opposite side. I'll move all this crap, this whole first term to the other side. Let's negative, make it positive. Divide both sides by 3. And I have, icky, but it works. Take the, I better make it a little bigger so we can all see it. Take the square root of both sides. I get x plus 2 equals plus or minus the square root of 5/3 or square root of 5 over the square root of 3. Got to rationalize, because what would the neighbors say? Square root of 3, square root of 3. Oh, that's, don't keep radicals in the basement. Neighbors might think bad of us. So I get square root of 15 over 3. Guess what? I just found the 2x intercepts. And man, was that fast? Yeah. But again, we can practice these over and over, and that's the way you get good at stuff, guys. Yep, as long as you pull from anywhere along here. I just think pulling from the very end is easiest. But yes, anywhere, you can grab anywhere along here instead of equal to 0. It always works. So if you have somewhere that you see that it's easier, grab that spot. And the next problem does, okay? The next problem does. So again, we've answered all the questions. This is the x-intercept, axis symmetry, y-intercept, max of 5, vertex. And we've just done f of x, the green function. So I'm going to gather all of this up down here, and we're going to get the red problem out. G of x equals x squared minus 6x next. On the next one, understanding that parabolas are symmetrical saves you a ton of time. You can complete the square here. I'm not against it. I will take 1 second to show it that way. Does everybody agree that it's going to be x minus 3 squared? Give it negative 6x, so I'm going to have plus 9 minus 9. And I'm not arguing that that's the vertex. It's not. We're going to save that. That works. But what I notice about the red is I would do this. Does everybody agree the red equation factored into this? And I know something, if I make this 0, I can find the roots of g of x. If I make this 0, I can find the roots. Well, we know that for g of x equals 0, x is 0, or 6 makes it 0. That's what makes these two parts 0. Well, I'm going to graph that right now. 0, 0, 1, 2, 3, 4, 5, 6. 6, 0. First of all, I just found the x-intercepts. And I also found the y-intercept this side. So if I go up here, the y-intercept is 0, the x-intercept is 0 and 6. The axis symmetry, what's between 0 and 6, everybody? 3. Guess what? I just found the axis of symmetry. Now, we also know that from here. All right? Is it a max or min? We know it's a min because it's positive in the front, so it opens upward. I might not know the value yet, but I know it's down here. I know it's a min of some value. And I don't know the vertex v yet. Though I know it's at 3. I don't know the y value yet. Now I do because I have that blue equation where I get to complete the square. But I'm going to do it this way. So you guys agree the sketch looks like this. So how do I find the y value? Well, if I know that the x value of the vertex is 3 here, okay? Can't I just plug 3 back into this equation right here? Yeah. And that's what I would do. 3 squared is 9, minus 6 times 3 is 18, so 9 minus 18 is negative 9. And for a sketch, I'm done. And the minimum then is negative 9. And I wouldn't have to do this. Not that this was hard this time, you guys agree? In fact, it was pretty easy this time. But again, we know this from this. We know it from the properties of parabolas that it has to be symmetrical across its vertex. Whoops. And it should go through 3. I'm just a little scaled off. But again, everything we want to know about this parabola very quickly. All right, h of x here. Whoops. I'm gonna erase. You want to erase it because I tell you what, it's going to be a fraction, right? So I'll pause the video and clean this up. Get the last one to go. Fractions make this ugly, but no different. The idea is still the exact same. When we have this h of x, we got to have it as a number times something squared. We got to have it in terms of this. A times x plus some b squared plus some c up. So we can shift it around the place, right? I don't care if it's fractions. But to get there, it gets ugly. So the first thing we have to do is factor out the coefficient on the lead term, which is 6. All right? When I get that, just because it's ugly doesn't make it any different. It's always the same. It's always a question of what plus what makes 7, 6, that middle term. Well, it's always half of this term. If it's 4, 2 plus 2. If it's 6, it's 3 plus 3. If it's 10, it's 5 plus 5. So 7, 6 is, half of 7, 6 is 7 12ths. So I can rewrite this, and I know that I am going to jump to this square. But if you have a binomial squared, you get a trinomial. And the trinomial this time means that you get 7 12ths plus 7 12ths to make 7 6. 7 12ths times 7 12ths, which is 49 1/44. There. But you can't just add 6 times 49 1/44, right? You have to also subtract that same amount. And I'll write it over here, 6 times 49 minus 144. And when I do this, the math becomes ugly. Grab my calculator and put a number here. So this becomes negative 625 over 24. And I'll believe that because I tell you what, it came from the book. 625 is 25 squared. 24 is going to take some work, but that's all right. We now know where this parabola is. It is shifted negative 7 12ths to the left, down negative 625 24. It opens up by a multiple of 6. We know the vertex, we know the axis symmetry, we know a lot of stuff. So we can start sketching this graph very quickly and filling in our data. All right? So I'm going to go to 100% screen. We're going to do this fairly quick to the end of this video. All right? Here I go. Negative 7 12ths, and I'll just write this as V. Negative 7 12ths, comma, negative 625 over 24. It opens up very quickly. If I go to the original problem and plug in 0, if I go back to the top, you guys read, if I plug 0 into h of x, the y-intercept is negative 24. So my graph is horrible. I'm going to fix it probably a little bit. Because I showed it, oops. I'm going to erase that curve and move it back. Because I showed it going, if it's going to go through negative 24, all right, this point's down here. Negative 24 is probably right somewhere in here. There. There's the curve, all right? The y-intercept is negative 24. The min, right, because it's the minimum, because it's opening up, is the negative 625 over 24. And finally, that leaves the axis symmetry. Well, the axis symmetry, again, is always the x-coordinate of the vertex. So x equals negative 7 12ths. And now, x-intercept. Yeah. I'm going to use this function and set it equal to 0. And the step I'm going to skip, I'm going to put 0 here and move the 625 to the other side. So I can write immediately this. Divide both sides by 6. Oh, there's nothing pretty about this. So 6. Oh, I like this.
Yeah, it got better.
It got better. 625 over 144. Take the square root. X plus 7 12ths equals plus or minus the square root of 625 is 25. And then square root of 144 is 12. Move 7 12ths. And look, it's even a common denominator. How much does the book like you guys? So negative 7 plus 25 is 3/2. Negative 7 minus 25 is negative 32 12, which is negative 8/3. And we just found the two x-intercepts. So negative 8/3 is over here. And 20, boom. And it gets quick. And we have just done 3 parabola problems.
That was a lot of work.